Chapter 7, a tale of three intersecting lines. A triangle is the most basic closed shape, the smallest closed shape with line segments, that is triangle. It has three corner points. These corner points are called vertex. Here the vertex A, other corner B, third corner C. Here X, Y, Z. These corner points are called vertex. The three line segments, that is called side of the triangle, AB, AC, BC are the side of this triangle. Here XY, XZ, YZ, UV, UW, VW are the side of the triangles. Here we can see triangles come in various shapes. It's based on its side length and also angles. Here in general we can write a triangle is having three sides. Example AB, BC, AC. Three angles. Angle A, angle B, angle C. Same thing we can write as this angle we can also write with a three-letter form. BAC. Angle BAC or angle CAB. This angle we can write ABC or CBA. This one we can write ACB or BCA. This is in the three-letter form, and this just a single letter, angle A, angle B, angle C. Also three vertices, point A, B, point C. Then sum of all three angles is equal to 180 degree, which means angle A plus angle B plus angle C is equal to 180 degree. This is what is coming in this chapter. Then triangles, different shapes of triangles, that is based on sides and also based on angles. Based on sides, we can classify into three type of triangles. Equilateral triangle. Equilateral triangle means all sides are equal in length. Then all angles are also equal. If sides are equal, angles also it will become equal. Each angle is 60 degree. So all sides are equal, equilateral triangle. Isosceles triangle means two sides are equal and its two angles are also equal. Scalene triangle, that means all sides are different. So angles also different. This is based on sides, three names. Equilateral triangle, isosceles triangle, scalene triangle. Same way triangles based on angles. Three types are there. First one, acute angle triangle. If all three angles are less than 90 degree, that means acute angles. Then we can say that triangle is acute angle triangle. Right angle triangle. One angle is 90 degree, that means right angle. Then obtuse angle triangle. One angle is more than 90 degree, which is called obtuse angle. So based on angles, three names. Acute angle triangle, right angle triangle, obtuse angle triangle. It's based on the angle. Acute less than 90 degree, all three angles. Right angle means 90 degree, obtuse angle means more than 90 degree. Based on sides, three names are there. Based on angles also, three names are there. This is the classification of triangles based on sides and based on angles. Based on this, that different shapes we are getting. The triangles when we are drawing, according to the measurement, with different shapes, it will come in different shapes. Here they are saying triangles come various shapes, that based on the angles and sides. Now this is the angles in three-letter form and in single-letter form. What happens when three vertices lie on a straight line? Three vertices means A, B, C. All 3 points, if it comes in a straight line, we cannot form a triangle. They become collinear. Collinear points means in a straight line. That cannot form, or we cannot draw by using these 3 points a triangle. Cannot form a triangle. Next is equilateral triangle. We already have seen equilateral triangle means all three sides are equal. Equal lengths. Then construct an equilateral triangle of side 4 centimeter. So for that, first we have to draw a 4 centimeter line segment, and then draw a circle with A as the center and radius 4 centimeter. Same radius we have to take in the compass and make a circle. Same way, B as the center, draw another circle. It will intersect at this point C. Here also it's coming. We are take this point as C. And join A to C, B to C, AC and BC. This is also 4 centimeter. All three sides with 4 centimeter, which means the required equilateral triangle with 4 centimeter. Next is constructing a triangle when its sides are given. How do we construct triangles that are not equilateral? Here construct a triangle with a side length 4 cm, 5 cm, 6 cm. For that, first we have to draw a line segment of 4 cm and A as the center, take 5 cm in the compass and draw a circle. Again, B as the center, take 6 cm as the radius and draw another circle. We can see it is intersecting at this point, that we can mark as C and join A to C and B to C. We will get the triangle ABC with this side 4 centimeter and this circle from A as the center, which means 5 centimeter is the radius. So 5 centimeter here, this side is 6 centimeter. Construct triangles having the following side lengths. All units are in centimeter. First one 4, 4, 6. To construct the triangle, first we have to draw a line segment of 6 AB as 6 centimeter. Here the measurement is given 4, 4, 6. We can take the longest one as the base. So AB is equal to 6 centimeter. Then after that, draw a circle with B as the center and radius 4 centimeter. Same way, C as the center and radius 4 centimeter. And then join AC and BC, we will get the circle. So for that, first we have to draw the line segment AB 6 centimeter. Then take 4 centimeter in the compass and just draw the circle. So now need the circle. Actually here this part arc is need enough. This arc. Same way from B also 4 centimeter. It will intersect at this point. That point we can mark as C. Then join BC and AC. Here two measurements with a 4 centimeter, 4, 4. So we have taken that BC 4 centimeter, AC 4 centimeter and the longest one BC as the AB as 6 centimeter. Now ABC is the required triangle. For the second measurement 3, 4, 5. Here the highest longest side is 5 with 5 centimeter. So we can take the line segment AB as 5 centimeter and A as the center, take near compass 3 centimeter radius, the other measurement, and draw an arc or circle. And B as the center, same way with 4 centimeter, draw the arc or circle. And the intersecting point of the arc, that is C. Try the measurements. AC is 3 centimeter, this side is 4 centimeter and AB is 5 centimeter. Join AC, BC. So ABC is the required triangle with the given measurements 3 centimeter, 4 centimeter, 5 centimeter as the side. Next question with the 1, 5, 5. 1 centimeter, then 5 centimeter and 5 centimeter. So in this case, first we can take the longest means 5 only. 5 centimeter as the base. So we can draw any letter you can give here. PQ is equal to 5 centimeter. So draw the line segment from P to Q as 5 centimeter. Then from Q, take 5 centimeter as the radius. Same radius and draw the circle. Then remaining 1 centimeter. From the other side P, from point P, take 1 centimeter as the radius in your compass and P as the center. Just draw the circle. Then we can see that circle and first circle that is intersecting at this point R. And by using the scale, join these 2 points PR. Also QR. So here PQR is the required triangle. Here this side PR is 1 centimeter. RQ is 5 centimeter, PQ is 5 centimeter. Two sides 5 centimeter, one side of the triangle is 1 centimeter. That's the steps. What we are doing, the same thing we can write in sentence. Draw PQ is equal to 5 centimeter and Q as the center with 5 centimeter as the radius. Draw a circle. P as the center and 1 centimeter as the radius. Draw another circle. Both arcs or circles are intersecting at the point R. Join PR and QR. Then PQR is the required triangle with the given measurements. Next one with 4 centimeter, 6 centimeter and 8 centimeter. The longest one 8 centimeter. So we can take that as the base. AB is equal to 8 centimeter. Draw a line segment from A to B with the scale 8 centimeter. Let's draw that one first. And take in your compass 4 centimeter as the next measurement is 4 centimeter. So 4 centimeter in your compass and A as the center. Just draw the arc or circle. Same way 6 centimeter as the radius and from B draw the another arc. It will intersect at C, join and write the measurements. This is the required triangle with the given measurements. Last one there with all measurements 3.5. For that also the same way, first we have to draw a line PQ as 3.5 centimeter. Then take 3.5 centimeter in your compass and Q as the center, draw the arc or circle. Same way P as the center, the same measurement, draw the arc or circle. It will intersect at the point R and join PQR with all three sides are 3.5 centimeter. If all three sides are in equal length, that triangle is called equilateral triangle. Figure it out. Page number 150. First question. Use the points on the circle and or the center to form an isosceles triangle. Isosceles triangle means two sides are equal. So use the points on the circle. Points on the circle means on the circumference. Anywhere 2 points you can take it. If you are taking these 2 points as A and B, then the point, the center that we can mark as C, and join AC, this is the radius of that circle, CB, that also radius. So we can see the radius of that circle anywhere if we are drawing, that will be equal in length. So AC is equal to BC. These two sides are equal. Now join the third side of the triangle, A and B, AB. So here we are getting a triangle ABC with the two sides are equal. So we can say this is an isosceles triangle using the points on the circle and the center. Same thing here also with the center C and 2 points marked as P and Q. Anywhere on the circle we can mark, any direction. Wherever we are marking, we can see the radius will be always equal. That means two sides of the triangle are equal. Then the third side is PQ. So this triangle is an isosceles triangle with, that means one of the point as the center and the other 2 points on the circle. Second question, use the points on the circles and or their centers to form an isosceles and equilateral triangles. The circles are of the same size. So first we can consider the isosceles triangle here. For that, the intersecting points, these are the same radius with the center A, this circle, and center B, the second circle. We can see that both the circles are intersecting here. So we can join that points by using the scale. So we will get the length, and the intersecting point we can mark as P, Q. And then if we are joining A to P and A to Q, same way BP, BQ. Here we can see AP is equal to AQ. So the triangle APQ, triangle APQ, same way BPQ are isosceles, which means BP and BQ are equal. So BPQ and APQ are isosceles triangle. Then to make an equilateral triangle, join the centers A and B. So from A to B, this is the radius of the first circle or the second circle, both are same. AP is the radius of the first circle, BP is the radius of the second circle, but both the circles with the same radius. So AP is equal to BP and that is equal to AB. This is an equilateral triangle. APB is an equilateral triangle, same way down also. AQB is an equilateral triangle. These two are equilateral triangle, these two are isosceles triangle. You can see here that same thing bigger. From A to P, that means AP is the radius of the first circle, AQ also the radius, AP is equal to AQ. Then in triangle APQ, these two sides are equal. Similarly, BP and BQ are the radius of the second circle, which means these BP is equal to BQ. So in this triangle, BPQ. Here in this triangle, these two sides are equal. In this first triangle, these two sides are equal. Two sides are equal, then we can say isosceles triangle. So these two are isosceles triangle. Then if we are considering this the way, the triangle, AB is equal to AP is equal to BP. Both the triangle with the same radius, AP is equal to BP and this also equal. Same way down, AQ is equal to BQ is equal to AB. So these are the equilateral triangles, two equilateral triangles, and these two are the isosceles triangles. Same way in the second figure, we can see three circles with the same radius. Same size means same radius. So first we can join AB, AC, BC. With the same radius means this is an equilateral triangle. And join this point that we can mark as P, this intersecting point as R, here Q. So PQR. Join with that point. Here we will get an equilateral triangle, all with its centers with the radius. So here we are getting 1, 2, 3, 4, all with the equal in length, all sides. So which means equilateral triangle. These all are the radius of each center. If you are taking this line, BQ, B is the center and Q is the point on that circle. So BQ is the radius. BC also radius of that circle. CQ is the radius of the third circle with the center C. But all circles have the same radius, which means all sides are equal. And all these equilateral triangles are isosceles triangle also. If three sides are equal, its two sides also will be equal. The same thing in this figure. ABC, then APB, BQC, ARC are equilateral triangle. Also we can write all these equilateral triangle are isosceles. Are triangles possible for any lengths? We can see that it is not possible for all the lengths. Can one construct triangles having any given side lengths? No. Then are the lengths for which it is impossible to construct a triangle? Yes. Here it is given 3 cm, 4 cm and 8 cm. Here we are not able to. Are you able to construct the triangle? No. If you are drawing by using this length 3 cm, 4 cm and 8 cm the triangle, we know that the longest side 8 cm we can take as the baseline and B as the center. Draw a circle 3 cm radius, A as the center, 4 cm radius, another arc or circle. We can see it is not intersecting. If these two arcs are intersecting, that point we can take that as the third point of the triangle. Here it is not intersecting. So we can write that not able to construct a triangle with sides 8, 4, 3 cm. Because the arcs from A and B do not meet. It's not intersecting. So here the answer is no. Again another question, another set of lengths 2 cm, 3 cm and 6 cm. That also the same way we can try. AB is equal to 6 cm. From B 3 cm radius draw an arc. From A 2 cm radius draw an arc. Gap is in between. It's not intersecting. So we can write not able to construct a triangle with measurements 6 cm, 3 cm and 2 cm. Because the arcs from A and B do not meet. So here also we can write the answer. Is possible for these side lengths? No. And next it is coming here, triangle inequality. To construct a triangle, always sum of two sides that will be greater than the third side. Triangle inequality, which means when we are drawing a triangle or constructing a triangle, for example PQR with 4 cm, 5 cm and here 6 cm. Now from R to P, this is the direct length. P or P to R, direct length. At the same time, we can reach, if we are starting with from R, we can reach P this way also by taking a round. So here, first we have to reach here and then from there to P. So we can see that always the direct length will be less than the sum of the other length or sum of the roundabout lengths or total lengths. Here PQ plus QR, PQ plus QR, that is coming is equal to 9 cm and direct length is 6 cm. That means direct length always less than the roundabout lengths. So that's the way we had to see here the figure. The same thing here it's given. The direct length from here to the tree, that will be always shorter than the other length, sum of these two sides. So when to construct a triangle, always some direct length that will be less than the other lengths, the roundabout lengths. Here in this page, Can we say anything about the existence of a triangle having side lengths 3 centimeter, 3 centimeter and 7 centimeter? That we can check that how to come that triangle. 3 centimeter, 3 and 7 centimeter. So first we are taking 3 centimeter. AB is equal to 3 centimeter. And from B, take 7 centimeter as the radius and draw an arc. It is going like this way. From A, 3 centimeter and take an arc. We can see it's going far, not intersecting. So the reason is triangle with the side lengths 3 centimeter, 3 centimeter and 7 centimeter is not possible because if we draw the arcs from a point A and B, they do not meet. At the same time, the measurements here it is given 3, 3 and 7. We are adding these two. 3 plus 3, that is coming 6, which is less than 7. So sum is coming less than the direct one. So always some direct path that will be less than the sum of the other path or the roundabout path. That's why it is not possible. Here the question the same way, is it possible in figure 7.4 the triangle is possible or not? When we are the direct path is 30 centimeter from C to A or from A to C. Roundabout path is coming 10 plus 15, 25. Now sum is less than the direct path or direct path is more length. That is not possible. So we can write it's not possible. There is any arrangement? So no. Now figure out page number 154. We checked by construction that there are no triangles having side lengths 3, 4, 8 and 2, 3, 6 centimeter. Not possible. Not triangles having. Check if could you found this without trying to construct the triangle. Without trying to construct, we can see 3 plus 4, that is 7. 7 is, and the other side is 8. Here the direct path is more than the roundabout path. So it is not possible. Here also 2 plus 3, 5. Direct path is 6 is there. So direct path is more lengthy than the roundabout path. So that type of triangles are not possible. This already we checked before here. This is the way. Now when we are considering the sum of two paths, the measurement is coming 3, 4, 8. So 3, 4, 8. When we are adding these two, it's coming 7, which is less than 8. That means direct path is more than the roundabout path. Two sums together, roundabout path, which is not possible. In this case, 2, 3, 6. When we are adding 2 and 3, these two sides, 5 and 6 is greater. So the straight path is greater than the roundabout path. That type of triangles are not possible. That we can write in sentence 3 plus 4, which is equal to 7, which is less than 8. So direct path is longer than the roundabout path. So therefore triangle cannot exist or triangle cannot form. Now second part, 2, 3 and 6 centimeter. 2 and 3 when we are adding 5 and 6 is greater than 5. Direct path is longer than the roundabout path. So triangle cannot exist. Now second question, can we say that anything about the existence of the triangle for each of the following length? Here 10 plus 10, 20. Direct path 25. So direct path is more than 20, which means triangle is not possible. So we can write in sentence that when we take direct path, that is 25 kilometer. The roundabout path 10 plus 10, 20 kilometer. Now Here we can see direct path is more than roundabout path. Direct path is longer than the roundabout path. Therefore, existence of triangle is not possible. Next measurement B, 5 mm, 10 mm and 20 mm. 5, 10, 20. So, direct path 20 mm. Roundabout 5 plus 10, 15. So, direct path is more than the roundabout path. Direct path is longer than the roundabout path. Therefore, existence of triangle is not possible. Next measurement 12 cm, 20 cm, 40 cm. Direct path 40 cm. Roundabout path 12 plus 20, 32. Here also direct path is more than. Always direct path supposed to be less than the roundabout path. So here direct path is longer than the roundabout path. Therefore, existence of triangle is not possible. Here third question, they are saying that we had to check all three measurements. For example, the first one 10, 10, 25. So here two measurements are equal 10. So there we will get two inequalities. If we are taking these two as the roundabout, 20, that will be less than 25, the direct path is not possible. If we are taking these two as the roundabout and 10 as the direct path, then 10 plus 25, which is equal to 35, and that is greater than 10. That means the sum is greater or the direct path is shorter, smaller than the roundabout path. This case is correct. But both or all the three inequalities, it comes same, then only we can construct the triangle. For example, here 10, 15, 30 centimeter. So first we are taking 10 as the direct path. Sum of the other roundabout 15 plus 30, that is greater than 10. If we are taking 15 as the direct path, then 10 and 30. 40, that also greater, sum is greater or roundabout path is greater, longer. At the same time, third measurement, just interchanging, 30 as the direct path, then 10 plus 15, 25. There the direct path is coming greater. These two cases are okay, but the third case, 30 is greater or the direct path is longer than the roundabout path, which is not possible to construct. All three inequalities everywhere, when we are comparing, everywhere the direct path supposed to be shorter than the roundabout path. Then only triangle can construct. This we can check in the rest of the cases also. 5 mm, 10 mm, 20 mm. First we are taking 5 as the direct path. So 10 plus 20, sum is longer, roundabout path is longer. 10 as the direct path. So 5 plus 20, that is 25, which is longer than or greater than 10. These two are direct path, that is coming sum, direct path is less than sum of the other two. But if you are taking 20 as the direct path, sum of these two is coming 15 only. Here that direct path is greater than or longer than sum of the other two. Therefore, the triangle construction is not possible. Same way the next case, 12 cm, 20 cm, 40 cm. If you are taking 12 as the direct path, then 20 plus 40, sum is greater. 20 as the direct path, there are also the other two numbers, sum is greater. If we are taking 40 as the direct path, then sum is coming 12 plus 20, that means 32 only. This direct path is greater than the sum. So which is not possible. Triangle construction is not possible. So always sum of the or roundabout path, that will be longer than the direct path in all three cases. Now here, is it possible to identify which lengths will immediately be less than the sum of the other two without constructions? That we can find out which inequal is coming. The triangle is not possible. So we can write yes by considering the direct lengths in the increasing order. Then same as the previous question, we can see which one it is coming, is it possible or not possible easily. Now here each length is smaller than the sum of the other two. So to construct a triangle, always each length, that means direct length, that will be less than or smaller than the sum of the other two. This property, or that is called triangle inequality. So we can say if one of the direct path length is longer than the sum of the other two, then we can say surely that triangle is not exist. So to construct a triangle, the arcs supposed to intersect. So in this case, the arcs will not intersect. Now figure it out. Page number 156. First question, which of the following lengths can be the side length of a triangle? Explain your answers. Note that each set 3 lengths have the same unit of measure. First one, 2, 2, 5. So we have to check all 3 conditions. Here 2 side lengths are same. So 2 cases only we have to check. First one here, 2, 2, 5. Set of lengths can form a triangle only if each length is less than the sum of the other 2 lengths. This is the condition. First we are taking 2 here. The other numbers 2 and 5. 2 plus 5. So first direct length is less than the sum. This case okay. But if you are taking this as the direct length 5 and sum of the other 2 sides, that is 4. Here direct length is coming more than the sum, which means 2 to 5 by using that measurement cannot be the side length of a triangle. We cannot construct a triangle. This cannot be the side length of triangle. Next is here 3, 4, 6. Same way that also here. First we have to take 3 as the direct length. Sum of other 2 sides 4 plus 6. That is okay. Here 4. 3 plus 6. 4 is less than 3 plus 6. Then third number 6. That also less than the other 2. So each side length is less than the sum of the other 2 side lengths, which means triangle is possible. So we can write by using the measurements 3, 4, 6. That can be the side lengths of a triangle. Triangle is possible. So this can be the measurement of each side 3, 4, 6 like that way. Next number 2, 4, 8. First number 2, that is less than sum of the other 2. Next number 4, that also less than sum of the other 2. When we are taking the bigger number 8, which is greater than the sum of the other 2. So always direct path supposed to be less than the roundabout path, or each side supposed to be less than the sum of the other 2. This is not possible. So we can write triangle is not possible. Because of that itself, this cannot be the side length of the triangle. Next measurement 5, 5, 8. So that also the same way. First number 5, that is less than 8, 5 plus 8. And second number 8, 8 is less than 5. So 2 numbers are same. Only 2 cases we have to check. Here triangle is possible. All the case that each side is less than the sum of the other 2. So 5, 5, 8 can be the side length of the triangle. Next one 10, 20, 25. That also the same way here. 10 is less than sum of these 2. 20 is less than sum of the other two, and 25 is less than first two numbers, 10 plus 20. Therefore, triangle is possible. If triangle is possible, this can be the side length of the triangle. Next number is F 10, 20, 35. 10 is less than sum of these two, 20 also less than these two, but 35 is greater than the sum. Therefore, triangle is not possible and this cannot be the side lengths. Next is 24, 26, 28. If you are taking each side, 24 is less than sum of these two. 26 is less than sum of first and third. 28, third number is less than sum of first two. Therefore, triangle is possible and these can be the side lengths of the triangle. Here, how will the two circles turn out for a set of lengths that do not satisfy the triangle inequality? Find 3 examples of set of lengths for which the circles. First case, touch each other at a point. Second case, do not intersect. Touch each other at a point, that means we have to take sum of the two sides as same as the third side. So we know that to construct a triangle for the given lengths, the longest side that will be less than, or the direct side that will be less than sum of the other two lengths. Now just to touch each other, which means if you are taking 3 examples, first one 3, you can take any number like the same way. If you are taking 6, 2, 4, 2 plus 4, 6. So it is coming by touching each other. If you are drawing a line segment 6 centimeter and from here 2 centimeter the arc, from here 4 centimeter the arc, it will touch each other. Same way 5, 2, 3, 2 plus 3, 5. Here 3 plus 4, 7, the other number 7. So you can take any number like that way. Second case, do not intersect. So 3 plus 4, 7. Here 8. 2 plus 3, 5. Here 1 plus 2, 3. And 5. It's not possible at all and it is not intersecting. Do not intersect means if you are drawing in the line segment 8 centimeter here and from the first point 3 centimeter, it will come like this way 3, and 4 centimeter from here when we are drawing, it will go like this way. It is not intersecting each other. In this case, it is touching each other. So touch each other and do not intersect. Any 3 examples. Now the conclusion, if a given set of 3 lengths satisfies the triangle inequality, then we can say that triangle is exists with the given side lengths. If that does not satisfy the triangle inequality, then triangle with those side lengths does not exist. Now figure it out, page number 159. First question, check if a triangle exists for each of the following set of lengths. 100, 100. 2 measurements are same, so we have to check 2 cases. Same way we can see here, 1 is less than sum of the other 2. Then second number 100, that also less than sum of the other 2. So we can write that satisfies the triangle inequality. Therefore, the side lengths 100, 100 that exists the triangle. Triangle is existing. Next number 3, 6, 9. So 3 is less than sum of the other 2. 6 is less than sum of the other 2. But the third number 9 is equal to first and second. Is equal to. Always supposed to be less than. So we cannot construct a triangle by these measurements. You can write not satisfies the triangle inequality. Therefore, the side lengths, if you are getting like that way, that type of triangle is not existing. Next, 115. 1 is less than 1 plus 5. Last number 5 that is coming greater than. That also not satisfies the triangle inequality. So we can write that triangle inequality for side lines 1, 1, 5, a triangle does not exist. One more there, 5, 10, 12. So 5 is less than sum of these two, 10 is less than sum of the first and third, 12 is less than sum of first and second. So which satisfies the triangle inequality. Therefore, for side length, the given lengths can be, we can construct a triangle and the triangle exists. Second question, does there exist an equilateral triangle with a side 50, 50, 50? In general, does there exist an equilateral triangle of any side length? Justify your answer. So we can write that yes. Here we can see if we are taking 50, 50, 50 is less than sum of the other two. So always that inequality is satisfies. So we can write sum of any two sides is greater than the third side when we are taking any measurement. If all three measurements are same, that can construct an equilateral triangle. So in an equilateral triangle, all sides are equal, which means this condition is satisfied for any positive side length, any number. If we are taking, we can draw the equilateral triangle with the same measurement. All three sides are equal. Third question, for each of the following, give at least 5 possible values for the third length. So there exists a triangle having these side lengths. Here we can take decimal values. Here 2 measurements are given. We have to find the third one. For that, the third measurement lies between the sum of these two and the difference of these two given measurements. So we can take that as C as the third measurement. Let C be the third measurement. The sum of the given measures or the sum of the sides are 1 plus 100, 101. Difference of these two sides, that is 100 minus 1, 99. So the third side that will lie between this 99 and 101. You can take any number between this. So we can write in general 99, which is less than C, less than 101. That means the third side lies between 99 and 101. Here the question 5 values we have to write. So we can write after 99, 99.1, 99.2, 99.3, etc. Just below 101. So 100.1, 100.2, 100.4, 100.7. Any number you can write it in between 99 and 101. That can be the third side. Same way second one, 5, 5. Two sides are given 5 and 5. So the third side we can take as C. So sum of these two sides 10. Difference of these two sides 5 minus 5, 0. So third side can be any number between 0 and 10. Any number with a decimal or natural numbers. So between 0 and 10 means 1, 2, 3, 4, 5. That way you can take, or 4, 7.5, 5.5, 7.8, any number, any decimal. Only the condition that's supposed to be between the sum of the given sides and difference of the given sides. Any 5 you can write it. Next number 3, 7. So that also the same way. Third one we have to take as C. And sum of the given sides 10. Difference of these sides 7 minus 3, 4. So any number between 4 and 10. So 5, 6, 7, 8, 9 that you can take, or with a decimal. 6.1, 6.3, 7.2, 8.1, anything, any 5. Here the previous question, see that all possible lengths of the third side, that exactly in between the first one, all numbers strictly between 99 and 101. Same way, we have seen that the second number between 0 and 10 and the third number between 4 and 10. Now we can look at the figure it out. Next page, page number 161. First question, construct triangle for following measurements. 3 cm, 75 degree and 7 cm. Here the construction of triangle when two sides and one angle is given. First one 3 cm, 75 degree, 7 cm. The longer side 7 cm that we can take as the base. So first we have to draw AB as 7 cm by using the scale. Then from the point A, using the protractor, mark that 75 degree, mark it here 75 degree. Then using the scale, first we have to keep the protractor at the center and 75 degree mark it here. 0, 10, 20, 75, mark here. And then by using the scale, join the line with that point. Till here it is. But we need this side, it is 3 cm, the other side is 3 cm. So we need only 3 cm. So just take 3 cm from the center and mark that point as C. Then join BC. So we will get the triangle ABC with angle 75 degree. Second one 6 cm, 25 cm and 3 cm. For that also first the longer side 6 cm that we can first draw by using the scale 6 cm. Draw AB is equal to 6 cm. Then at A keep the protractor and 25 cm is the angle measurement. Here 20, 0, 10, 20, 25 is coming here. But we need the other side as only 3 cm. 6 already we have taken. Now the second side as 3 cm. So again by using the scale, we can draw that full if you want by dotted line like the same way. And we need only 3 cm. So from here till here 3 cm, mark that point as C. Then join AC and BC. This is the required triangle. Third one 3 cm, 120 degree, 8 cm. First AB is equal to draw a line segment. AB is equal to 8 cm from A to B. Then from A, take the protractor and keep at the center A. Same center as that point and baseline. Then we can see 120, it's coming here. We can mark that point. Then using the scale, join A to that point. Till here is that. But the second side it's given us 3 cm. We need only 3 cm in that line. So 3 cm, mark that. Then till mark the point and join. Same way BC also join it. So we will get the triangle with 8 cm one side, the other side 3 cm. The included angle, the two sides and the angle in between these two sides, that is 120 degree. Next is two angles and the included side. Two angles and one side we will get here. That type of question here. Figure it out, page number 162. 75 degree and 75 degree, two angles and in between the sides 5 cm. So first we have to draw 5 cm and keep the point protractor 75 degree both the end points, and we can construct that. Here is that. So first we have to draw AB, that is 5 cm. Then keep the protractor at A at this point. Now we can see from 10, 20, 30, 40, 70, 80, in between 75. This line. We can mark it here, that 75 with the dot. Same way from B also, that we can mark 75 degree here when we are keeping. But that is not intersecting. So we have to extend that line. Actually the point we got here and the other point is here. So just extend that line till the top. There are more, and same way this line also. So we can see these two lines intersecting at a point. That point mark as C. And right here 5 centimeter, both the angles 75 degree. So the triangle construction with two angles and the included side. Steps are here. First draw AB 5 centimeter. Construct angle A is equal to angle B, both with 75 degree. Then the point of intersection, that C, join AC, BC, and ABC is the required triangle. Second one, 25 degree, 3 centimeter and 60 degree. So that one 3 centimeter. First we have to draw the line segment AB as 3 centimeter. Then angle A 25 degree. Keep the protractor here. degree. Mark it here. That 25 here. Then BC as angle B as 60 degree. Keep the protractor there. B as the center. And 60 degree means 0. We have to start from the outer scale. 0, 10, 20, like that way. 60 is coming over here. Then join A and C. A and that point, like this way, dotted line. And B and the marked point for 60 degree, like the same way. We can see these two lines intersecting at this point. So ABC is the triangle. 25 degree angle A, angle B 60 degree, and the in between the side, these two angles and the side between, that means AB, is 3 centimeter. Next is 120 degree, 6 centimeter, 30 degree. First we have to draw a line segment of 6 centimeter. And then 30 degree and 120 degree. So same way from center A 30 degree. It's coming over here. From 120, B 120 degree. It's coming over here. And then extend that point. Join that A and the marked point is here. But we have to extend the line. Draw a bigger line. From B also the same way, that will intersect at this point. So that we can mark as C. So triangle ABC with angle 30 degree, 120 degree, and the side, included side, that is 6 centimeter. Here we can see angle A is 40 degree. The angle is an obtuse angle. So the line is going almost parallel. It's not going to intersect anywhere. In this the way, if you are getting the angle measurement, we cannot construct the triangle. So the rule is sum of the angles supposed to be 180 degree. Here the question, figure it out. Find for each of the following angles. Find another angle which the triangle is possible and also not possible. Find at least 2 different angles for each category. So the first angle is given 30 degree. We know that the sum is 180 degree, sum of all 3 angles. So first angle is 30 degree, which means the remaining 2 angles supposed to be 180 minus 30, that is 150. That's supposed to be 150. So we can find any 2 numbers such that sum as 150. 150 we can take, 90 and 40 we can take, then 60 and 90 we can take. Anyway, so that is possible. or any other measurements, the other angle sum is more than 150, that type of angles, then triangle is not possible. So we can write this way. 180 minus 30, that is 150 degree. So a triangle is possible only when if the other two angles is less than or equal to 150. So it's possible if we are taking 60 and 90. 60 plus 90, 150. Or another one, 150 we can take. That also 150. Or 80 and 70. 150. So we'll get different measurements. Any other measurement more than 150. So the another angle which a triangle is not possible will be any angle greater than or equal to 150. More than 150, then it is not. Any one angle is equal to 150 means there is no chance for the third angle. So any angle is more than that is not possible. Triangle construction is not possible. Next measurement is 70 degree. That also the same way. 70, first you have to subtract from 180. 180 minus 70, 110. So the sum of the remaining two angles supposed to be 110. 70 and 40. One example for that. 70 plus 40, 110, and the other angle is 70. So 70, 70, 40. 70 plus 70, 140 plus 40, it will come 180. Sum supposed to be always 180. Not possible. Any measurement you can write greater than 110. 120, 150 and that all. Now the third measurement 54. That also the same way. 180 minus 54, 126. So the measurement 72 plus 54. 126. So not possible means any measurement greater than 126. Next one, 144. So 180 minus 144, 36. So sum of two angles supposed to be 36. That way if we are taking two angles, then triangle is possible. 10 and 26, 36. So in that case 10 plus 26 plus 144 is equal to 180 we will get. Any other measurement above 36 for the angle, that is not possible. Second question here, determine which of the following pairs can be the angles of a triangle which cannot. So this with one angle is given, here two angles are given. We have to find the third angle measurement, which are possible and which are not possible. If the sum of three angles is equal to 180, then that is possible. Otherwise, that is, triangle construction is not possible. Now the first one, 35 degree and 150 degree. So we can take here sum of these two, that is 100. So the third angle supposed to be 180 minus 100, that is 80. So the given pairs 730 can be the angle of a triangle. If we are taking 80 is the possible case. That's the second case, B case, 70 and 30. First one 35 and 150. When we are adding, we are getting that is 185. 185 is greater than 150. Sorry, 180. 185 is greater than 180, which means that is not possible. Sum of three angles supposed to be always 180. All other cases, triangle construction is not possible. Here 35 plus 150 itself, it is coming 185. That is greater than 180. So triangle is not possible. Second case 70 plus 30, that is 100 only. So the third angle can be 80. Then that triangle is possible. Third case 90, 85. The measurement is here given 90 and 85. 90 and 85. And when we are adding 175 is coming. So the third angle possible, that is 5 degree. But that also can be constructed. So with the given measurement 90 and 85, that also triangle is possible. Here in the first case not possible, second case possible, and the next one 50 plus 150, that is coming 200, greater than 180, so not possible. So this is also not possible. Sum of all three angles. Sum of all three angles is equal to 180. Always supposed to be 180 degree. Then only we can construct the triangle. These two cases, it's more than 180, so not possible. Here, let us take two angles 60 and 70, whose sum is less than 180. 60 plus 70, 130 is coming. And which is less than 180, and the included side is 5 centimeter. What could be the measure of the third angle? So total supposed to be 180. Here 60 plus 70, 130, and the third angle will be 50 degree. Then all three angles together we will get 180 degree. Does this measure, here the side length is 5 centimeter. Here the question, does this measure change if the base length is changed to some other value, say 7 centimeter? Construct and find out. Here we can see the given measurement 70 degree and 60 degree. So the third angle will be 50 degree. We are constructing the line segment AB as 7 centimeter. From here 70 degree. From B 60 degree. That will intersect at C. And if you are measuring, we can see that is 50 degree. So the third angle, measure of the third angle will not change if the base change to 7 centimeter. If the angle, these two angles are same, whatever the length of the base, always we will get the third angle as 50 degree. The reason is sum of all three angles supposed to be 180 degree. Figure it out, page number 165. Find the third angle of a triangle using parallel line when two angles are given. Using parallel line we have to find out. So here two angles are given, 36 and 72 degree. So why we can mark that as here 36 degree and 72 degree. And draw a line, this is the base line BC. Draw a line parallel to BC through the point A. Parallel line. BC parallel to XY. Now this 72 degree and this angle will be equal. That also 72 degree. Reason is alternate angle. These two lines are parallel. These angles are alternate angles. Same way, this angle is 36 degree. So this angle also will be 36 degree. Alternate angles. Now we are going to find the third angle of the triangle. This angle is 36, here 72, and this angle. This is a straight line, XY is a straight line. So sum of all these three angles is equal to 180. 36 plus 72, we will get 108. So this angle is equal to 180 minus 108 is equal to 72. It's a straight line. So sum of all three angles is equal to 180 in a straight line. That we can write like the same way. HAB, this angle is equal to 36 degree, and YAC is equal to 72 degree, alternate angles. Then name of these three angles in three-letter form. HAB, BAC, YAC is equal to 180 degree. We know that this angle is 36 and this is 72. Then this angle A is equal to 180 minus 108 is equal to 72 degree. Same way, second question, B part, 150 and 15. So there also first we are drawing a triangle ABC like the same way. BC is the baseline. with the given measurements. 150 is the angle and here 15 degree. And XY parallel to BC passing through the point A. Now this 150 is same as this angle. That means XAB, which is same as angle B, 150 degree. Similarly, this angle C is same as this YAC. Alternate angles. Now here here we are getting 15 degree. This side we are getting 150 degree. Now sum of these three angles is equal to 180. So BAC, this angle is equal to 180 minus 150 plus 15, 165, which is equal to 15 degree. Next one, 90 degree and 30 degree. 90 is right angle triangle, 90 degree, 30 degree. There also XY is parallel to BC. So we can take this angle. It's parallel line, and here this is 90 degree, this also will be 90 degree. Same way this angle is 30 degree, this one is 30 degree. Now this angle BAC. So angle BAC is same as in the triangle, we can take that, consider that as angle A, which is equal to 180 minus 90 plus 30, 120, which is equal to 60 degree. Next measurement, 75 degree and 45 degree. Similarly, draw a triangle with base BC and 75 degree, 45 degree, XY parallel to BC passing through the point A. Now this angle is 75, which means these two lines are parallel. So 75 is also 75 degree. Angle XAB. Same way YAC. This is 45, this is also 45. Sum of all these three angles is equal to 180 degree because XAY is a straight line. Now 75 plus 45, that is 120. So this angle is equal to 180 minus 120, which is equal to 60. Second question, can you construct a triangle all whose angles are equal to 70 degree? All angles are equal, which means 70 plus 70 plus 70, it will become 210. 210, that is greater than 180. So not possible. If two of the angles are 70 degree, that means 70 plus 70 is equal to 140. Then what will be the third angle? Third angle will be 180 minus 140, that will come 40. Then if all the three angles have equal, then what is the measure of each angle? All the three angles, sum supposed to be 180. All three angles are equal, which means each angle will be 60 degree. So we can write this way, right? First case, that not possible because if all three angles with a 70, that will come sum as 210. That is greater than 180. So that is not possible. All three angles with a 70 degree, that type of triangle is not possible. Now say two angles with a 70 degree. So that will become 70 plus 70, 140. So the remaining third angle, that will be 40 degree. 180 minus 140, it will become 40 degree. Now if all the three angles are equal, then it will come sum is 180, that divided by 3. All three angles are equal. So each angle will be 60 degree. Third question, here is a triangle in which we know that angle B is equal to C. These two are equal. So we can take this as X. We don't know the measurement. Let it be X. These two are equal. Angle B is equal to angle C. So whatever the measurement here, that is same as here also. And angle A is 50 degree. Can you find angle B and C? We know that sum of all three angles is equal to 180. Which means X, here X is there, this also X. X plus 50 is equal to 180. That means 2X plus 50 is equal to 180. Which means 2h is equal to 180 minus 50 is equal to 130. Then h is equal to 130 divided by 2, which is equal to 65. So each angle, that means angle B is equal to angle C, which is equal to 65 degree. So we can write angle B is equal to angle C, which is equal to 65 degree. So if we are adding, we can say 65 plus 65 we will get 130. That plus 50 we will get 180. So one angle is 50. Then these two angles are equal. Then we can find that as each one is 65 degree. The sum of three angles of any triangle, always that will be 180 degree. This property is known as angle sum property. So angle sum property means sum of all three angles is equal to 180 degree. This we can prove through the paper cutting using the triangles. Here ABC, the angle means angle ABC. Draw a straight line and cut this corner, this angle B and angle C from there. And this angle C, keep it here, this side. Angle B, keep it here. So we will get together same as a protractor or semicircle, same as a straight line, which means straight line that representing 180 degree. So sum of three angles is equal to 180 degree. That is called angle sum property. Next one is exterior angle. So exterior angle means the outside angle. We know that the angles inside the triangle, three angles are there in a triangle. So inside the angles are called interior angles. Angle A, angle B and angle C is that. So when we extending one line, we will get outside one angle, exterior side. So that angle is called exterior angle. If we are extending this line, we will get here an exterior angle. If we are extending this line to this side, this is an exterior angle. So we can see the exterior angle and inside the corresponding angle, these two together 180 degree. These two together it will come 180 degree here also, because it's a straight line. It's a straight line. Now again, this exterior angle that will be equal to sum of these two angles, sum of the interior opposite angles. These are interior angles. So this exterior angle that is equal to sum of the interior opposite angles, not this interior angle, opposite side, opposite angles. Sum of the interior opposite sides. So here we can write that angle ACD is equal to angle A plus angle B. Interior angles, sum of the interior angles. Here the question, do you see any relation between the exterior angle and these two angles? So we can write here exterior angle is equal to sum of the interior angles. So the relation is, can you find? Yes. So that is that here. So we can write in both the properties together. First is angle sum property. So angle sum property means the sum of the angles of a triangle is always 180 degree. That means angle A plus angle B plus angle C is equal to 180 degree. Now here the exterior angle property. That means exterior angle is equal to sum of the interior opposite angles. This angle is same as angle A plus angle B. Sum of the opposite interior angles. Now the proof of that we can write here by angle sum property, angle A plus angle B plus this angle. This angle means angle ACB, which is equal to 180 degree. This by angle angle sum property. Already we noticed that here sum of all three angles is equal to 180 degree. So angle A plus angle B plus this angle is equal to 180 degree. That is equation number 1. Then second one, here we can, when we are considering this a straight line. So these two angles sum supposed to be 180 degree. Angle ACD and angle ACB, these two angles. So that is equation number 2. When we are considering these two equations, we can see right sides are equal. These sides are equal, then left side also will be equal. So from here we can cancel this ACB and from both the side. Then what we are getting? ACD is equal to A plus B. This angle is equal to sum of these two. So that is the proof. Sum of exterior angle is equal to sum of the interior opposite angles. Now this we can, if we are extending this line, exterior angle will come over here. That angle is equal to some opposite. It's this vertex opposite angle. That means Q and R. So this exterior angle SPR is equal to angle Q plus angle R. If we are extending to the other side, this side, this is outside angle, exterior angle, ACD. It's this vertex, its opposite side means this one, and the angles on that side, angle A and angle B. So this angle ACD is equal to angle A plus angle B. So which side we are extending there, that exterior angle. If we are extending to this side, this is the exterior angle and its opposite angles. Sum of the interior opposite angles. Sum of the interior opposite angles is equal to this exterior angle. Construction related to altitudes of triangle. Altitude means the perpendicular distance or the straight distance from one vertex to the opposite side. Here we can see BC is the opposite side of this vertex. So AD is the perpendicular and this will be 90 degree. Perpendicular means 90 degree. So AD is the altitude to the base BC. Same way we can draw the altitude from B, this vertex, to this side, AC. Similarly, from C also we can draw like the same way. So in one triangle we will get 3 altitudes. Here we can see the other altitudes of that one from B to AC. Opposite side of B, that is AC. Perpendicular. BE is the altitude to AC from B. From C towards AB. That means CF is the altitude. In the case of an obtuse angle triangle means more than 90 degree. In this case, from this vertex A, the altitude means straight line, perpendicular line. It is coming outside the triangle, not inside. So we have to extend this line and we can see this is the altitude in the case of obtuse angle triangle. Altitudes of a triangle. Here is an acute angle triangle. Here the altitude is coming inside, interior, inside the triangle. From the point P towards here, the opposite side QR. PS is the altitude. This is a right angle triangle. Right angle. So the altitude means this side. PQ is the altitude. It's a perpendicular distance from P to the opposite side. That means the one of the side of the triangle itself. In the case of obtuse angle, this is an obtuse angle triangle. There, that altitude, it will come outside the triangle. So we have to extend this line and from this point A towards that baseline. So AD is the altitude in this case. So acute angle triangle, altitude will be inside the triangle. right angle triangle altitude, that will be one of this side, PQ itself. Obtuse angle triangle altitude, that will be outside the triangle. So altitude is the perpendicular drawn from a vertex to the opposite side. A triangle has three altitudes from all three vertices. We can draw from here to here and from here also. Same way from this one here, like this. So here AD is the altitude from A towards the side BC. Then BE is the altitude from B to this side AC. CF is the altitude from C to the side AB. Construction of altitude by using scale and set square. For that, take any one side of the triangle. Now here the triangle ABC, take this side, keep the scale there, same as the picture. Keep the scale here in that baseline, and on top of that you have to keep the set square in 90-degree position, like the same way, and just move. Scale, keep it straight, same as that, without moving, and only set square you have to move till this the vertex A. Now we can see the vertex A, it's stretching like the same way, and keep both the same way, and using the pencil from A we can draw the line towards this. So this line, that will be the altitude, like the same way. At the way we can draw the altitude in a triangle using ruler and set square. Here right angle triangle. This type of triangles are called, one angle is 90 degree. So that is called right angle triangle or right triangle. Here the altitude is coming from A to BC. That is AB. Here different types of triangle. Already we discussed that based on sides. If all three sides are equal, then equilateral triangle. Two sides are equal, isosceles triangle. All three sides are different, then scale and triangle. Same way based on angles. If all three angles are acute, less than 90 degree, then that is called acute angled triangle. If one angle is 90 degree, right angle triangle. One angle is obtuse angle, then obtuse angle triangle. In acute angle triangle, all three angles are acute. Acute means less than 90 degree. Types of triangles already we discussed, that is based on two way. One is based on sides. Equilateral triangle, which means all sides are equal, and in this case all angles also will become same, 60 degree. All sides are equal, then all angles are also equal. Isosceles triangle means two sides are equal, so its base angles are equal. Scale and triangle means all sides are different and all angles are also different. Now the same thing based on angles. Now all three angles are acute, which means less than 90 degree. That is called acute angled triangle. One angle is 90 degree, that is right angle. Then it's called right angled triangle. One angle is obtuse, more than 90 degree, then that is called obtuse angle triangle. These are the names based on angles. Here these three are the names of based on sides. Triangles name based on sides and based on angles. Figure it out, page number 170. Construct a triangle ABC with BC 5 cm, AB 6 cm, CA 5 cm, and also construct altitude from A to BC. We have to look at the question from the vertex A to BC. For that, first we have to draw a line segment AB as 6 cm and take 5 cm in your compass. Draw an arc from B and also from A. It will intersect at this point C. Then join A to C, B to C. Now we got the triangle ABC with the side 6 cm and these two sides 5 cm. Now here the question, we have to draw an altitude from A to BC. For that, from A to the side BC, that's the question. So we have to keep the scale there on the BC side here, in that line, and take the set square. So keep that angle 90 degree perpendicular like the same way towards the scale, like the same way. Then keep the scale straight like the same way without any movement. Only with set square you have to move like the same through the scale. Now like the same way we can, when we are moving, we can see from A, from the vertex A. So mark that point A like the same way. Correct A when it comes, we have to stop it there. And keep both scale and set square without moving. Then draw the line. Now here we are getting this, we can mark as any point D. So AD is the altitude from the vertex A to BC. Steps, if you want, we can write that as easily. First we have to draw a line segment AB. First point we can write, draw AB is equal to 6 cm. Then A as the center, B as the center, take 5 cm and join or draw the arc. Intersecting point, mark that as C. Then join AC and BC. Then keep the scale on that side BC where we need the altitude, that side. Keep scale here BC on that line segment and move the protractor from this side to here. We will get from A to BC and AD as the altitude. For the second question, the construction, here it is given RY 4 cm and TR 7 cm. We can take TR 7 cm. So draw a straight line 7 cm and mark that as T and R 7 cm. Then angle R is 140 degree, which means this angle is 140 degree. For that, we have to take the protractor, keep R as the center, like the same way, and 140, which means from this side, 0, 10, 40, 50, 90, 100, 40, 140 is coming over here, 140 degree. And join that with R. You can draw that by dotted line. Like that way that line is going. But here it is given RY is equal to 4 cm. Y is the new point. That is 4 cm only need. So from R, take 4 cm till here. That point we can mark as Y. Then join T and Y. This angle is 140 degree. And this side RY, that is 4 cm. So TRY is the required triangle. Now here we have to construct, first we completed the triangle construction. Now we have to construct an altitude from T to RY. From T to RY. So we have to keep the scale there on the RY, that baseline. and keep the set square. Here altitude from T to RY. So we have to keep the scale over there on that RY and the set square. Keep on the scale. From T, when we are marking like that, we can see it is not coming the edge or that corner on T. When it is moving, it is going like that way. So just you have to adjust the scale like the same way, and again you try where it is coming. Now we can see that is coming from that point T. Here. Keep the set square and scale together, touching like the same way without no gap. And now we can see that is going through. If we are drawing a line that is going through T. So we have to draw a line there like the same way. But now we can see that is not on this side. For that we have to extend this line also. Like this way. Now we can see this is the altitude. Here T, we can mark that as X, this point. So this TX is the altitude of this triangle from T to RY. Why it is coming over here? Because this is an obtuse angle. So that altitude will be always outside the triangle. So obtuse angle triangle, its altitude is coming outside the triangle. So from T to this side, that is extend this RY, it is coming over here, TX is the altitude towards RY from T. Question number 3. Construct a right angle triangle ABC with angle B 90 degree. That means right angle triangle, and AC 5 centimeter. How many different triangles exist with these measurements? So we can construct a triangle like the same way. ABC, AC, you can take any side, and angle B is equal to 90 degree here. A small line 90 degree and this side is 5 centimeter. That's the way first we have to draw this and join. Also we can draw that here angle, here it's given. Not that other measurements can take any values. Take AC as the base. Here is saying AC as the base, which means 5 centimeter we have to take as the base. So we can draw that way. AC as the base and from angle B as the 90 degree. Here the question, what values can angle A and angle C take so that the other angles is 90 degree? So one angle is 90 degree. Then we know that sum of these two angles supposed to be 90 degree. Total is 180. So if you are taking this as 60 degree, this also this will be 30 degree. 60 plus 30, 90. That 90 plus 90, 180. This is already 90. If you are taking this as 60, this will be 30. If you are taking this 40, then this will be 50. If you are taking this as 45, this will be 45. 45 plus 45, 90, 90 plus. Sum always supposed to be 180. One angle is 90, which means that the way we can take the other two angles. So each angle, according to the each angle, when it is changing, the shape of the triangle that will change. So we can write shape of the triangle will change with the different values of A and B. But there are infinitely many triangles are possible. So we will get different angle measurements such that sum is 180 and one of the angle is 90 degree. Now the fourth question. Through construction, explore if it is possible to construct an equilateral triangle. Right angled, obtuse angled. So we can write that equilateral triangle, always the angle is 60 degree. In the case of equilateral triangle, already we noticed that 60 degree. But with right angle means already one angle is 90 degree. Obtuse angle also means more than 90 degree. So with that It's not possible at all. The other two angles, all angles will not come same as 60. Already this 90, this is more than 90. So not possible. That we can write. It is not possible to construct an equilateral triangle that is right angled or obtuse angled. Equilateral triangles, angle measurement always be 60 degree. Next is also construct isosceles triangle that is right angled and obtuse angle. That we can do. Isosceles triangle, right angled triangle, one angle is 90 degree, then the remaining 180 minus 90, 90 it will come. So these two will be 45. These two sides are equal. Isosceles means two sides are equal and two angles, its base angles are equal. So 45 each. Then obtuse angle also we can construct. If we are taking, for example, this as 120 degree, then the 180 minus 120 it will come. 180 minus 120